I want to thank Presence for hosting this event, and I thank them for this beautiful bow tie. I feel a little bit guilty wearing it, being a Duke Blue Devil, but Rob is wearing one as well, so I don't feel quite as bad. What I want to talk about, and I've characterized it as the witch and the geek, is an adventure that Duke's embarking on in terms of how do we build a culture for supporting data science in an academic health system. And I'll be honest, I don't think we have all the answers yet, since this is probably a new adventure for many institutions. But I wanted to share some anecdotes about how we've done this, and hopefully these will be useful for you all. And in many ways, what I think this adventure is showing us is that what's old is new again, and I'll get to that at the end of my talk. So one thing I want to ask you all is, who said this? Healthcare is like witchcraft and just based on tradition. Does anyone happen to know? It's a Silicon Valley denizen. Yeah, Vinod Khosla, right? And he additionally said 80% of healthcare can be automated. And actually, I was sitting in the room at Strata RX, which was an O'Reilly conference back in 2012 when he first started talking about this. And as I was sitting there in one of the few MDs in the room, since it was in San Francisco and surrounded by you geeks, I was actually a little bit taken aback. And I thought about, wait, let's see, I spent 4 years in medical school, 5 years getting a PhD, residency took me 5 years in general surgery. So that meant I had wasted 11.2 years of my life on witchcraft. Now, so this is the paradigm I think we were working with in working with data science. And I think the themes that have come out over the talks preceding this with Dr. Topol and Dr. Lee is that there needs to be conversations, right? There need to be conversations between the witches and the geeks. The witch is tradition, right? So as someone who trained in general surgery at Duke, I have a tradition that I can easily hearken back to. William Halsted was the father of American modern surgery. He was the first one to actually use rubber gloves. And his future wife actually was complaining about how carbolic acid would create a rash on her hands. So he asked Goodyear to make some rubber gloves for her. So that changed surgery significantly. Later, chair of surgery at Johns Hopkins, Alfred Blaylock, who was a protege of Tinsley Harrison, who wrote Harrison's book of internal medicine, father of congenital heart surgery. And David Sabiston at Duke, a legendary academic chair, first to attempt coronary artery bypass. So there's a witch and wizardry lineage that certainly I, as a general surgery resident at Duke, was hearkening back to. And as Dr. Tierney had mentioned, we think about clinical pearls. We take these precious pieces of knowledge, we accrete some beautiful layer around them, and we hand them on from generation to generation. And that certainly harkens back to an old time in medicine. Yet the geek wants to say this, right? The geek wants to say 80% of what you all do can be automated. And that indeed, medical diagnosis is an easy problem if you have the data. Now, we can argue about whether that actually genuinely is the case. But let's actually concede that to Mr. Khosla and say, okay, fine. We can, write some code, and we can come up with a very good classifier. But in the end, there are lots of questions that we can't really answer, right? So, for instance, if right now, and perhaps different institutions are better than Duke is, if I asked at Duke, what's this month's door-to-balloon time for heart attack patients, it's hard for me to get that information. If I ask how many of our chronic disease patients have a documented advanced care planning discussion, that's very hard to get to. So yes, okay, if we concede that diagnosis is easy if you got the data, well, do we really have the data, right? And that's a question. And I think all of us realize it's sort of that water everywhere but nothing to drink. We're surrounded by data, yet it seems very inaccessible. Last week I visited UPMC, University of Pittsburgh Medical Center, and they've actually done a good job in terms of categorizing and cataloging all the information they have. And this is an image from one of their slides. And when you look at what they've got 1,102 apps generating data at an academic health system like UPMC. And data domains encompass 2,885 data domains. And you think about Epic, Epic notoriously has 18,000 data tables in Clarity, which is their data warehouse. So how do we actually access all that information well? So if that witch wants to ask a question, or that geek wants to actually provide tools to answer a question, we still have a lot of data that is essentially inaccessible, atomized, and siloed across many different spaces. So one approach that UPMC, and actually coincidentally Duke, has started thinking about is, should we layer something on top of all those data? Should we layer something like an operating system, right? Because people want to write apps, but if you go on your laptop, you still need an operating system for Microsoft Word to work. So can we use the concept of an operating system to inform how we think about all the data that we have, all the systems that we have? Our faculty are CPUs, right? Our EHRs are our data storage. So how do we make those accessible in a useful way? So medical diagnosis is an easy problem if you have the data. Here's a datum that I want to start thinking about. And this is, I think, getting back to the old way of thinking about things. Here is Betty C. She's a patient seen at Duke Connected Care, which is Duke's accountable care organization. Betty is a 65-year-old woman with a history of myocardial infarction. She's had a cabbage. That's a coronary artery bypass graft. She has congestive heart failure, and she happens to be a substance abuser. She doesn't see her primary care provider that much. So she was last year admitted to the emergency department for chest pain and pulmonary edema and admitted from the emergency department. Yet after discharge, she still has very few primary care visits, and hence she's really almost invisible to the health system in that way. So she's lost in the shuffle. As I mentioned, Duke Connected Care is an accountable care organization at Duke, which is one of those Obamacare innovation models. What that means is that it's a Medicare shared savings program, Track 3, which means Duke assumes upside and downside risk, financial risk for taking care of this primary care population, as long as it also meets certain quality metrics. And so one question we had thinking about patients like Betty is, can we project every patient's risk of unplanned admission over the next 6 months? And if we can do that, can we find patients like Betty, right? She doesn't see her primary care provider that much. So most of healthcare is very encounter dependent. So we obviously want to, if we're thinking about humanism, we certainly want to take advantage of those encounters. But there are going to be many cases where actually there's stuff going on and the patient's essentially not visible to us. So what we did is we embarked on a project called Deep Care Management. And what it is we put on our miners' helmets, our construction workers' helmets, and we spent a lot of work looking at the claims data and electronic health record data. So the claims data is provided by the Centers for Medicare and Medicaid Services as a flat file. And for those of you who are technical, that's oh gosh, we're getting flat files from CMS. So we spent a lot of work thinking about how do we turn those flat files into readily machine analyzable form. And then we have electronic health record data. And luckily, since Duke happens to be the coordinating center for PreCoreNet, which has a common data model, we took advantage of that ability to abstract Duke electronic health record into a common data model. And then Larry Caron, who's the vice provost for research at Duke, happens to be a well-published machine learning researcher. He'd used Poisson deep factor networks for analyzing health record data, so we employed that. And our job was can we predict across 31 diagnostic categories or any diagnostic category? We basically used a custom roll-up of ICD codes to do this. So we expressed these to care managers as 6-month probability, both in absolute and percentile risk. And we decided to see what would happen. So to recap, we have a 6-month prediction window. We're predicting the probability of any unplanned admission, any cause, 31 diagnostic categories. And so we're projecting that at the beginning of every month. And we use 12-month retrospective claims data. So those claims data are refreshed on a monthly basis, so we refresh the predictions and the model on a monthly basis. And we use the past 10 years of their electronic health record data. This model we build, as I mentioned, on a monthly basis, and we retrain it on a monthly basis. So we're looking at 52,000 patients in Duke Connected Care. We're looking at 32 predictions. that risk stratification is shown to care managers, and the care managers have now reconstructed their case management workflow based around those predictions. And as I mentioned, for someone like Betty, who doesn't see her primary care provider, since she's had encounters, since she's had claims, we can actually still see her. We can actually still see her as a patient. And incidentally, at a place like Duke, 50% of the claims that you'll see in someone's insurance record are actually at an outside institution. So the claims give us visibility to any interactions with healthcare outside of Duke, while the electronic health record gives us deep introspective ability to see into what's going on with them specifically at Duke. And then the important thing is this: we're keeping a registry of all our results and looking at our interventions, looking at our outcomes, storing the model versions, right, since we're retraining models on a monthly basis. And the important thing is this: we're data scientists. So we're not saying this is, we obviously have great, retrospective model performance, but we're also asking Duke's new Population Health Sciences Department to do a prospective, real-world evidence, essentially an individualized step wedge study, so that we can actually evaluate ourselves. Because CMS doesn't actually allow us to run a clinical trial on a MSSP population, but we can do a real-world evidence outcomes-based study. And we hypothesize that this essentially represents a prototype of what would be a data science module for our learning health system, because now we have a way for care managers to provide us feedback and integrate those into our models. We have models that will learn over time. And we have an independent real-world evidence evaluation plan and a goal to ultimately expand into other primary and specialty care domains. Now, all these dots that are showing up are all the different kinds of people we have working on this project. And you can see that's a pretty diverse group of people, ranging from MDs, pharmacy, doctors of pharmacy, social workers, RNs. These are all core people on the team for deep care management. So I think what this represents is at least the human ecosystem around a data science project. And then when you think about all the different pieces that we've used to do this project and some of the future pieces that we're using, for the geeks in the room, these are all very recognizable logos for computer languages and capabilities and APIs and version control systems. But when you think about it, these things are not things that exist in the EHR. So when you need a runtime to run Python, for example, can Epic give you a runtime to run that? No. Can Epic do continuous integration and continuous testing? No. So we have a little bit of an impedance mismatch between what the EHR vendors want to give us, and they want to control everything, right? So Epic wants to sell us all the modules that we need to do things. So, and that's natural, right? You assume that's going to be the case for a vendor. And Epic is now proposing that they have a machine learning runtime that we ought to buy instead of trying to do it for ourselves. But I think what's important for us in an academic health system is think, we know what we need. We shouldn't let Verona, Wisconsin, or Kansas City, Missouri dictate what we do. We should do what we need to do, and we should think of the EHR as just one piece of an ecosystem. And if that ecosystem requires Kubernetes, if that ecosystem requires different versions of Linux or TensorFlow, then we should actually build that ecosystem and not let them dictate what we do. So this system is really an ecosystem of people of different capabilities with a patient right in the middle, and all these different tools, and whatever tools we need to do the jobs that we think we need to do as people taking care of patients. So the one thing I want to say is, most people focus on building the apps, but what we really should be thinking about is building the ecosystems that support those applications. And then we need to make the underlying data services easier to write the apps. Because if we have the underlying data services, the app part is actually the easy part. And I think for most of you who've done machine learning, usually it's getting the data to the state where you can actually run, you build your algorithm. That data cleanup, data munging stage is usually 80 to 90% of your work. And it's actually fun to do the machine learning part. So we need to spend our time still on that part. Lots of people are persevering about the app, the front end, but we really need to build the data underneath. So for those of you who are not amongst the geeks, I thought it might be useful to talk about the Cheesecake Factory and APIs. As many of you know, Atul Gawande has used the Cheesecake Factory as a as a metaphor for how healthcare should standardize its delivery and things like that. I'm going to take the Cheesecake Factory into the informatics room and talk about APIs. So, as Atul Gawande said, you walk into the Cheesecake Factory. It's sort of Disney-like experience. You sit down and they hand you this menu, and obviously this menu is the same menu that's probably served across 200 cheesecake factories across the United States. And what this menu really represents is an abstraction of the kitchen, right? So you honestly probably don't want to know what goes on in the kitchen in the Cheesecake Factory, but you certainly, you're at the mall, you want to have a meal of quality that you can expect. So what goes on in the kitchen is stuff you don't have to see. The menu really is a representation of what the Cheesecake Factory has to offer to you. So let's say you're interested in Renee's Special. So that Renee's Special is a service that kitchen provides. It's an item. It's a service. So you talk to your server and say, I want Renee's Special. The server writes that down on a guest check, takes it back to the kitchen. That's a service request. And you have your service fulfilled. And I think this is a useful metaphor for how APIs work. And certainly what, right now, our current generation of electronic health records does not provide to us in a robust way. Because if you imagine that if you try to think of the informatics equivalent of the kitchen and Renee's Special, is the kitchen, is gathering and data, doing all that curation and gathering of data elements. Let's say the 18,000 data tables in Epic into data elements that are clean and relevant to MI. And then you can provide the APIs that give you all the data elements you need to make a prediction about MIs. So this is obviously the way virtually all modern applications work, yet for some reason, even though health records are new to us, they don't operate this way. So the question is, can we get the EHR vendors to give us a good Cheesecake Factory menu? So, right, Cheesecake Factory is a great analogy for delivering healthcare. It's actually a good analogy for delivering data to application creators. In many ways, you can think of a clinical application as like a meal. You go into Cheesecake Factory, you order an appetizer, a main course, then a big, very unhealthy piece of cheesecake. You can think of a clinical application as being the same thing. It's a collection of API calls that help you do something interesting with business logic. So what I would say is that in terms of the living in the world of the witch and the geek, it's not this 80-20 relationship that Vinod Khosla has asserted. It's that we actually really should have a 50-50 balance between the witches and the geeks. I've obscured them, but with our deep care management project, I ask the case managers to actually send me narratives of the individual cases. Not all of them, but give me cases, because I want to hear about these on a monthly basis. We've only started running since December, but they've sent me these cases. So it helps me understand, do we need to change our interfaces? Do we need to change how we threshold a predictive model? So this is how we connect anecdote with the big data that we have available to us. And I want to end on a historical note. The MIRU is the Myocardial Infarction Research Unit. This was a unit created at Duke. I think the original NIH call for proposals was in 1969. Dr. Stead asked a gentleman named Frank Starmer, who's a computer scientist, to work with them to put together a proposal for the Myocardial Infarction Research Unit. And Frank Starmer, being an engineer and a computer scientist, built these wonderful machines. So this is the architecture from 1970 for one of these machines that is pictured here. So here's a machine sitting in Duke's CCU in 1971. It's a myocardial research unit monitor. I hear that it could collect stroke volume at minute-to-minute resolution for these patients. But the ironic thing was all this data being collected, at least from the 1970s era, there was an interesting debate going on between Dr. Stead, who is a legendary chair of surgery at Duke, of medicine at Duke, and Frank Starmer. And one thing that Frank Starmer observed was, well, the nurses aren't using all this data that are streaming to us. And Dr. Stead said, well, Frank, now that you've discovered that I was correct about patient monitoring, what are you going to do with all this expensive computer equipment that we bought for you? And Frank Starmer said, I need help. I need to understand how clinicians deliver medicine. So what happened afterwards was that Frank Starmer started rounding with Gene Stead on the general medicine service on a weekly basis. And supposedly he did that for many, many years, to the point where when Dr. Stead was going around and pimping the medical students with questions, that Frank Starmer was as good, if not better, than the medical students. And so what I would argue, too, is as much as we now need physicians who have some exposure to data science or informatics, is we also need to turn that around and actually have our data scientists, our pure quants, really see how clinical medicine is done. So, for instance, I've sent one of my data scientists to the emergency room. And what I would propose that, at Duke, as we build out the Forge, which is our health data science initiative, is that we actually have enough, basically a transfer of experience, where we have the data scientists really see how clinical care is provided so that they can understand what these kinds of things that we've been talking about all day clinicians face, and so that they can build services that better serve us and our patients. And that's my last slide.
Very good. Thanks so much, Dr. Huang, and a great overview of all the really infrastructure that's needed. As you say, some people, I think Nigam Shah likes to call it the data janitorship is where most of the work is. But if we don't do that, well, who is going to do that? And again, I don't know what your thoughts are on that.
Well, I think that's where we need that 50-50 split, because when you dive into clinical data, and remember, most of these clinical data, especially with electronic health records, are actually generated by clinicians, right? They're entered by clinicians. So for you to understand all the subjective factors that are buried in those data, the biases that are buried in those data, I think it's very important for clinicians to remain involved. I think, when I was at Sage Networks before I came back to Duke, we created these clean data sets so we could run machine learning challenges. The problem is we presented a clean data set, right? And in many cases, for instance, we normalized out hospital site in one data set, and before we'd done that, the machine learners had been using hospital site as one of the predictive variables. Well, if you want a generalizable model, you don't want to embed the Brigham into a data set. So it's important for us to be really engaged in that curatorial effort, because we know the data, we understand how we entered the data, and it's only by having that dialogue with the pure quants that we can really do a better job in curation.
Yeah. I was thinking about some great comments about culture relays of change that has happened as well. Atul Gawande referenced we need to be thinking about pit crews rather than cowboys for doctors. But I was not selected into medical school for being a replaceable cog in a machine. I was selected for being the best guy I could be. And what are we training for, and what are we selecting for in that case?
Well, I think data integration is still something that requires a lot of human intelligence with. I'll give you an example. When I was an intern at Durham Regional, or now called Duke Regional, which was our regional community general hospital, I noticed that all our patients were hyponatremic. So, but yet the individual attending surgeons who were going in seeing their patients were, treating their hyponatremia, putting them on hypertonic saline, cutting off their IV drips and things like that. But as the intern seeing the whole service, I knew everyone was hyponatremic, and of course to me it's like, well, there's something going on here, right? We need to explain this. And I called the lab and they said, oh yeah, our machine's miscalibrated. So that's where, there's no predictive model to do that kind of inference and integration yet. So I think that we still need to be in the driver's seat. Just like a Boeing 787 Dreamliner is probably incomprehensible for us in terms of an engineering standpoint, I don't think that a pilot can fix a 787, but a pilot sure knows how to drive it and sure knows what to do when things happen. So I would say the analogy is the same for those of us in medicine.
A lot of your comments were about kind of what the EHR should do and why are we bound and held to this. I'll reference a quote that the EHR, it's used by people who care about the patient. It was built by people who care about the computer, and it was selected by people who care only about the bottom line. So yeah, there probably is a lot of things it should do, but why should they do anything different?
Right. So I totally agree with Dr. Topol. Basically, for some reason, we let ourselves out of the driver's seat when it came to selecting these systems. We need to be back in the driver's seat. We need to participate fully in identifying the things that we use to take care of patients. Would a CIO feel like he could tell a surgeon what kind of stapler to choose? No.
I don't know, actually. The COO,
all right.
maybe.
Yeah. But in any case, I think we need to be fully participatory as we think about the future, because we know, I mean, I think Vinod Khosla is, of course, he's got the vector right. There's going to be a lot, the 80% of stuff that doctors do that should be automated is the 80% of the documentation and paperwork and misery. The vector is correct. So we need to be part of deciding which one of those 80% that we are, allocating to the machines.
Awesome. Last comment or question from Jessie Dunn. She talks about why do we even have such a fixation on the EHR? There
Right.
are many other sources of data that maybe even matter more, like perhaps maybe patient-generated data streams.
Absolutely. Rob talks about this all the time at Duke, is like, what about the 99% of data that exists out of the EHR, right? One, the EHR is not designed to handle genomic data or wearable device data. Why should we expect, to get that through MyChart or something like that? We really should start thinking about how do we integrate that EHR. It's just one part of that ecosystem with the other parts of the data ecosystem that we have for patients. Absolutely.
Very good. Well, thank you again one more time, Dr. Huang. Great presentation and great thoughts on the infrastructure.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.